Hi everyone, it's 9:30, so let's get started. Welcome to Modules and Services. My name is Alex Buckley. I work in the Java Platform Group at Oracle. I edit the Java language specification and the Java virtual machine specification, and for many years now I've been working on, have worked on the module system that's in JDK 9. Can I do a couple of straw polls whilst I have you all here? Who has downloaded JDK 9, please? Quite a few hands. Who is familiar with metainf/services? A small number of hands, okay. Who is familiar with Java util service loader? Some of the same hands, but also different hands, which is quite interesting. Who has built an application that calls service loader? A small, right, we're already shrinking, okay. So that's what this talk is about. I often say that modules are quite different than most language features such as lambdas. Lambdas are about the shape of programs in the small, individual for loops turning into method calls with lambda arguments. You can reshape a program to use lambdas without anyone noticing. Modules are about the shape of programs in the large. We deal with classes and packages and get bigger from there. If you reshape a module, it's quite likely that other people will notice. And although modules are expressed in source code of the Java language, they are in some ways outside the language. They define architecture rather than code. I say all this because services that I'll be talking about here are the purest form of architectural construct offered by the module system. They're something you have to design for very explicitly. It's actually possible that in your daily work you will never come across services. And also, if you're thinking SOA, service-oriented architectures, that's not what this is about. Was anyone thinking SOA? No, I guess I can take that line out of the presentation. So now that we're here, let's talk about three things. What services are in JDK 9, what they can do, and how they can make old code more modular. So, what are services? And I should also check, did everyone see the keynote on Monday? Who didn't see the keynote on Monday? It's a bit unfair. Okay. Okay, some people. Has anyone seen any other modularity talks? Oh, good. Quite a few hands. So that's good. So this is additive to those. So you'll build up from there. So when we talk about modules, we typically talk about two things: module dependencies and package exports. Java Desktop is the JDK module that contains AWT and Swing. As you can see, it expresses a dependency on the Java XML module for some internal implementation reason, so that it can access all of the public types in the API exported by Java XML. And Java Desktop exports the Java AWT package, so that anyone who requires Java Desktop can themselves access the exported public types of the AWT API. The coupling between Java Desktop and Java XML is very tight. If Java XML isn't found at compile time, then Java Desktop, which requires it, cannot be built. And if Java XML isn't found at runtime, then no system depending on Java Desktop can start, since Desktop's dependency on XML is unresolved. There is another kind of coupling between modules that is much looser than that. It's so useful that we've built it into the module system. It involves one module requesting an implementation of an interface, and other modules providing implementations of that interface. I'm actually going to say that again because that's what this entire presentation is about. One module requests an implementation of an interface, other modules provide implementations of that interface. As an example, The Java desktop module could request an implementation of some print service lookup interface, while another module, printlib, has some class that implements print service lookup. At runtime, code in the Java desktop module, to do with printing, can call a simple standard API to obtain an instance of print service lookup. The instance in this case would be of class fastprint from the printlib module. But Java desktop does not require printlib. This means that Java desktop can be resolved by the module system even if printlib is not present at compile time or runtime. Also, printlib would not export the package that contains that fastprint class. Fastprint is a class, it's not an API that other modules should access directly. Other modules, like Java Desktop, should invoke methods of fastprint only through the print service lookup interface. What do the module declarations look like for this relationship? It's very simple. Java Desktop would say that it uses print service lookup, and the printlib module would say that it provides print service lookup with the fastprint class. Print service lookup is called the service type. The service type is usually an interface, but it can be an abstract class or even a concrete class if you really have a need for that. Fastprint is the provider class. The provider class must be a concrete class that implements or extends the service type and declares a no-args constructor so that it can be instantiated by the module system. We say that Java Desktop is the consumer module. He's got sort of the dark blue arrow. And printlib is a provider module. He's got the purple arrow. Notice in Java Desktop that you are seeing requires take a module name, Java XML, exports take a package name, and uses take a type name. 3 different properties of a module, 3 different keywords, 3 different kinds of arguments. The provides in printlib takes 2 type names, one for the service type and one for the provider class. And that provides directive is the modular equivalent of a file called metainf/services/print service lookup that would have listed the fastprint class prior to JDK 9. If a jar file has a module info class compiled from this module declaration, then any files in metainf services are ignored. The module declaration's idea of users and provides wins. Just to clarify what's going on here, there is no dependency injection here. If your module says uses some service type, and you have a field of that service type, then it is not the case that an instance of that service type is magically assigned to the field. You have to ask for an instance of the service type explicitly. So let's talk about that. To obtain an instance of the print service lookup interface, code, hypothetical code, in the Java Desktop module employs the service loader API introduced in Java 6. The key method in service loader on the second line is load. It takes a class object, javalang class, representing a service type, so print service lookup.class. As long as Java Desktop is containing this code says that it uses print service lookup, that load method returns a service loader object capable of yielding instances of that service type. The module system works behind the scenes to assist service loader. The module system automatically discovers provider modules at startup by scanning modules in the Java runtime image and modular jars on the module path. Now there could be lots of provider modules. There could be more than one provider module for print service lookup, which means more than one provider class that implements the interface. Each instance that service loader yields of the service type is of a different provider class. Helpfully, service loader implements iterable, so the PSLs, which is the service loader object, implements iterable, so you can for each your way through the available instances known to service loader, looking for the one you like. In this case, Java Desktop hopes to find a print service lookup implementation that offers a specialist print service involving a particular doc flavor. I don't know what doc flavors are, but I know they're to do with print service lookups. If service loader yields no instances of print service lookup, or if it did, but for some reason none of them in the for loop body there could offer the specialist service desired in this case by the code, then the code has to decide what to do. In this case, it decides to return a default print service object. Now, all of this code would typically live in a static method of the service type, so that print service lookup is its own factory for obtaining implementations. Now, before JDK 8, interfaces couldn't have static methods. So most service types, print service lookup, were abstract classes rather than interfaces. But now that interfaces can have static methods, it's more common for the service type, print service lookup, to be an interface. At this point, everyone asks, if service loader finds all provider classes that implement that print service lookup interface and yields an instance of each one, how does Java Desktop that contains that code specify that fastprint is my favorite implementation of print service lookup? Alternatively, how does the printlib module specify that my class fastprint is the best implementation of print service lookup? Trust me. The other question everyone asks is about ordering. How does Java Desktop, the consumer module, specify that it prefers the fastprint implementation of print service lookup to the netprint implementation, but that it will be happy to run with netprint if fastprint is not present? Now, bear in mind that provider modules on the right usually don't know about each other, so they cannot reasonably be involved in selecting or sorting implementations. The consumer module, Java Desktop, is obviously the right place to do it, but this quickly leads to complicated schemes that encode provider preferences in a module declaration. Now, we're trying to keep the module system simple, so the answer is no one specifies a global sort of static preference for provider classes, at least not in a module declaration for the consumer. Instead, the basis for choosing one provider class over another is application dependent. It's a choice the consumer module has to make by inspecting the properties of available provider classes when they come back from service loader. And by properties, I don't mean reflecting over their fields. I mean calling methods of the service type on every instance of the discovered provider classes. So recall that Java Desktop, this is code in Java Desktop, calls after it's got the service loader and it's iterating through the print service lookup implementations. It calls the get default print service method on each instance of print service lookup, and then makes further calls on the result, is doc flavor supported, to decide if that instance is acceptable for whatever Java Desktop is trying to do. The consumer module should not be concerned with the identity of the provider classes. The provider classes are private details of the provider modules. In fact, we strongly discourage provider modules from exporting its provider classes, because if they're exported, it encourages people like this guy to code around the interface and directly against the class, at which point you've lost the benefit of loose coupling. So my advice is to think of a service type, the interface for which implementations will be found, as a coarse-grained selector. A service type, like print service lookup, should offer enough descriptor methods about the quality of implementation for a consumer module to select the best provider class. In our example so far, print service lookup, the service type print service lookup, is actually a proxy for the real print service objects of interest. There may be many instances of print service lookup on a system in different modules, each one representing many instances of print service, but able to offer a default print service to consumers. In another scenario, the service type might directly represent an object of interest. In this example, the print service interface itself at the bottom actually offers a rich enough set of descriptor methods, .flavor related, that it could perhaps be a legitimate service type of its own. How much abstraction you design into your service type depends on your application. The main factor is how heavy the ultimate objects of interest are. For example, if the nature of one of these print service things is that instantiating one might be slow, perhaps because a provider class might scan the network looking for printers, then there is value in print service lookup instances to act as proxies that decide whether a print service instance is actually available. But if the nature of a print service is that it's cheap and easy to instantiate, then the value of print service lookup as the proxy service type is diminished. And I hope it's clear, this is nothing to do with, services are nothing to do with print services. Services are a completely general mechanism, but to exemplify them, I have to get a concrete service, a particular service type and a small set of provider classes. And then the question is, great, I've got multiple provider classes, what do I do? Of course, the other question is, what if I have no provider classes? What do I do? We'll come on to that. It's interesting to look at the service types, the interfaces, consumed by Java Desktop. The service types in blue are proxies or factories or wrappers if you prefer. Print service lookup is among them. Where is he? There he is in the middle, print service lookup. The type next to it, stream print service factory, is the same deal. And looking from the top, you would call methods on instances of input method descriptor in order to find the one that offers the desired input method, capital I, capital M. And you would call methods on instances of image input stream SPI, service provider interface, to choose one that can best convert your data into an image input stream. The Java doc for those 5 SPI types, sort of near the top, even says, the intent is that it be relatively inexpensive to load and inspect all available service provider classes, i.e. implementations of image input stream SPI. Those classes may then be used to locate and instantiate more heavyweight classes that will perform actual work. In this case, instances of image reader, image writer, image transcoder, image input stream, and image output stream. The service types in brown are not proxies or factories, but rather they represent the actual objects of interest. So while MIDI device provider, sort of in the middle, in blue, is just a proxy for obtaining MIDI device objects, MIDI file reader, just below it in brown, is real business logic. A provider class for MIDI file reader knows how to obtain actually a MIDI sequence from a file. The bottom line is that the service loader API and the module system are agnostic about the granularity and design of your service type, which means that details like quality of implementation issues are kept out of the module declarations. Now you may be wondering, where do the service types, the print service lookup interface, actually live? A service type is just an interface in a package in a module. That package will almost always be exported from the module, all those green arrows, so that other modules, such as Java Desktop as a consumer and PrintLib as a provider, can require the service types module and access the service type. A consumer module like Java Desktop needs to access the service type for its uses directive, the dark blue arrows, and for the code that employs service loader to get instances of the service type. In other words, the print service lookup type name is actually in the code of Java Desktop, so there's a real access across modules there. A provider module, like PrintLib or NetPrint, needs to access the service type for its provides directive, and of course for the class, fastprint or netprint, that actually implements or extends the service type. In general, there can be many consumer modules on the left and many provider modules on the right for a given service type. A consumer module will say requires and uses, while a provider module will say requires and provides. The arrows look complicated when they're all drawn out, but browsing the source of module declarations, requires, uses, requires, provides, makes it pretty clear what the module relationships are. And by the way, this to some extent is irreducible. Even if you were doing a service loader prior to 9, this is what was really going on. These are the essential relationships between the consumers and the providers. The good news is if you skim, for example, the JDK module summary, or even the Java doc produced from your own modules, it's very easy to see which modules are consumers and of what, and which modules are providers and of what. And that's definitely an advance over grepping for service loader.load calls and wondering which jars on the class path have files in metainf services. All that said, it's not mandatory for a service type to be defined in a different module than the consumers and providers. In the JDK, it's common for a module which defines and exports a service type to also be a consumer module for that service type. For example, the Java Desktop module exports the Java AWT im spy package at the top so that other modules can implement the SPI types and act as provider modules. And Java Desktop uses, at the top on the right, Java AWT im spy input method descriptor so that code in Java Desktop can use service loader to get instances of that service type. Many well-known frameworks in the JDK, such as logging, file system, and datetime, support this kind of customization via provider modules. It's also relatively common in the JDK for a consumer module to also be a provider module. For example, Java Desktop uses print service lookup, really does. And also it provides an implementation in the form of sunprint print service lookup provider. This allows the code in Java Desktop that returns print services to be assured that it can always return at least some instance of a default provider class, sunprint print service lookup provider. Ultimately, you can see that a single module like Java Desktop may contain the service type and the uses directive to help the code employing service loader, and provides directives to specify one or more provider classes. So that's what services are. Service relationships, users and provides, are a first-class thing in the module system. Programming against service types, being a consumer module, allows the provider modules and the provider classes to be strongly encapsulated. And many JDK frameworks use services, I shouldn't say use, because uses is a keyword, build on services, rely on services, and are customized with them. So, moving on. How to use services for a particular use case. It should be obvious that services let you plug in implementations that weren't known to your program at compile time. They are discovered dynamically via Service Loader. For examples that show this, I recommend the Java 9 modularity book that's out this week. It's not so obvious that services are actually the key to encoding a number of sophisticated relationships between modules that might otherwise appear to be unsupported by the module system. In particular, I'm going to talk about how optional module dependencies are neatly encoded with services. As an example, consider the Java scripting module in the JDK. It offers an API to evaluate snippets of code. The details of that API don't matter. There is some class eval that evaluates snippets of code. Now at runtime, there might be many implementations of scripting languages capable of evaluating snippets, such as Nashorn, that's Oracle's implementation of JavaScript, or Groovy, or JRuby, etc. How is the Java scripting module meant to depend on them? It seems like we need a way to say in the module declaration for Java scripting requires optional module name, so that Java scripting would read whichever modules are available, and if none are available, that would be okay. The module system would still start, even though some of the required things might not be present. The trouble with requires optional is that it would only make sense when the Java scripting module has already been built. But suppose you're at compile time. What if source in the Java scripting module refers to a class in one of the optional modules, either JDK scripting Nashorn or Groovy Script Engine, and that optional module isn't present at compile time? It's not acceptable for a Java compiler to proceed when it can't find classes referenced in source code. Nor do we want to relax the Java language with some form of loose dynamic typing that says, well, I see there's a reference to some type from an optional module, and it's not here at compile time, but it might be here at runtime, so I'll just compile it and hope that the types will work out. That's not really the Java way. Now, you can get a bit further if you would, in your source code, never refer directly to class names from the optional modules, and instead access them via reflection. But that's a very painful programming style. It's how you had to code on the Java ME platform when different devices implemented different APIs, and you had to dynamically discover what was there and code it through the reflection API. It just doesn't scale. This is a slide you will want to take a picture of. The proper way to program against 0, 1, or many modules is with services. Services introduce a level of indirection by means of the service type. You can mechanically translate an optional module dependency at the top. I should say sort of a hypothetical optional dependency. You can't write requires optional, right? It's a hypothetical thing. But if you want to write that, you can translate it to a pair of non-optional dependencies on the module which exports the service type. There's a consumer module, Java scripting, which is going to use the service type, and then various provider modules on the right that require the service type module so they can implement Script Engine Factory, and they declare that they provide implementations. This scheme at the bottom decouples the number, and the identity of the provider modules on the right from the consumer module, which is what optionality is all about. I recognize this is an abstract picture. The benefit is it fits on one slide. Does this make sense? It's very hard to tell up here whether this programming idiom that we've burned into the Java language with these keywords, uses and provides, which is clearly more about the architecture of and the relationship between different modules. It's sort of the opposite of lambdas in their individual expressions in method bodies. It's very hard to tell how well it comes across. But really, this is the essence of modularity. It's about making the consumer modules not care who the provider modules are. Modularity is basically about not caring, and services are how you do that. You just rely on a well-designed service type, and you let the module system find the providers. So, since JavaScripting is a JDK module, it will not come as a surprise that it's not only the consumer module that says uses, but actually also where the service type lives. So at the top, the JavaScripting module, it both uses the script engine factory interface because there's code in JavaScripting that calls service loader, and JavaScripting actually is where that interface lives, so it exports it for everyone else to implement. Then further down, the Nashorn and Groovy modules, again, all hypothetical. There isn't actually a Groovy module called that, but I've got to have some example. They each provide their implementation of Script Engine Factory, and the module system discovers the role of these two modules as provider modules when the system starts up, assuming that jars for these two modules are on the module path. Now, code in JavaScripting, let me find my pointer. Code in JavaScripting can employ service loader to get instances of Script Engine Factory and call its methods without worrying where the implementations come from. The Script Engine Factory interface has many descriptor methods to let provider classes encode the quality of implementation of the script engines they ultimately offer. I'm not going to show Script Engine Factory because it will be a big long list of get methods. It's pretty easy to look up, and you'll see it sort of get the name of the script engine and get some details of what it, sort of the language features that it supports. You'll notice the JavaScripting module does not say requires JavaScript, JDK scripting, Nashorn, or Groovy script engine. In fact, if you look closely, you'll see that those modules require JavaScripting where the service type lives. So in effect, the way you get optional dependencies with very loose coupling is by inverting them. Rather than a high-level scripting API module requiring lower-level implementation modules, everyone looks up by requiring the module with the service type. So service relationships encode optional module dependencies. That means that services are not just giving loose coupling as sort of a mechanism in the module system, but actually better separation of concerns between the interface and the implementations. And services are almost always a better choice for discovering implementations than messing around with reflection, class.forename and the like. So, nearly done. Let's talk about cycles. This is a graph of some of the modules in JDK 9. What do you notice about it? It is acyclic. There are no cycles. There are no loops. It is a directed acyclic graph. The module system does not allow cycles in your requires directives. It has taken almost a decade to detangle the tens of thousands of classes in the JDK to the acyclic and relatively sane state you see here. We'd like to keep it that way. In fact, one of the motivations for investing in modularization of a codebase is the knowledge that once complete, there won't be any backsliding into the ball of mud that cyclic dependencies allow. And we're not the only ones who think like this. Java Application Architecture from 2012 is an outstanding book about modularity. In a section entitled, you actually couldn't make this up, but it's true, Cyclic Dependencies, the Death Knell, it says, excessive dependencies are bad, excessive requires basically are bad, but cyclic dependencies are especially bad. It goes on to say, generally speaking, cycles are always bad. However, some cycles are worse than others. Cycles among classes are tolerable, assuming they don't cause cycles among the packages or modules containing them. Cycles among packages may also be tolerable, assuming they don't cause cycles among the modules containing them. Module relationships must never be cyclic. However, in real life, there are sometimes cycles which seem inevitable. Let's look at a real-life example. Let's assume there is a logging project that consists of two modules, logging API and logging impl, one requiring the other. So the logging API module requires the logging implementation module. That's the blue arrow. Why? Well, maybe a static method in the API module has been traditionally using reflection to create instances of the logging implementation. Now let's assume there's some HTTP client module in an unrelated project. It wants to log HTTP requests. So it starts to require, another blue arrow, the logging API module. There are no services yet, it's just two requires. And finally, let's assume that the logging implementation module wants to add a feature where it can upload logs to a web server. At this point, the author of logging impl is out of luck in JDK 9, because for logging impl to depend on HTTP client via a requires, the third blue arrow, would create a cycle. And worse, it would create a cycle across projects. That's a very uncomfortable level of coupling to manage for the rest of time. What can the author of logging impl do to upload logs to a web server? Well, one option is to find another project that offers an HTTP client module, but that seems like cheating. Another option is to email the author of the HTTP client module and ask them to stop requiring logging API. But now the author of HTTP client is the person in the position of find another project. Even if the author of HTTP client is willing to use a different logging system, the author of logging impl would still have to wait for a new release of HTTP client that did so. Who is at fault here? It's not the logging impl module, who is just trying to reuse. Remember in the keynote, Mark said a module is a set of packages designed for reuse? The logging impl module is just trying to reuse the logically independent HTTP client module. And I don't think the problem lies with the HTTP client module, who is just trying to reuse a public logging API. The fault lies with the logging API module. It is poor style for an API to require its implementation, for two reasons. First, it means implementation details are likely to leak into the API, which makes the API less understandable. Second, it means that exercising the API needs the entire implementation to be up and running, which makes the API less testable. Plus, given everything I've said so far, it's kind of obviously wrong. Consider the Java base module. It declares the Java util collection interface, but it will be stupid for the Java base module to depend on, to require, any module that implements that interface. Implementations depend on interfaces, not the other way around. So the best outcome is for logging impl to depend on logging API rather than the other way around. Implementations depend on interfaces. But then I hear you ask, how does the static method in the API create instances of the logging implementation? Of course, with services. Here's what the logging project should do. First, the logging API module defines a service type, logger, in some package, and that package is exported widely, the green arrows, exported to consumers, exported to providers. Second, the logging impl module becomes a provider module. It requires logging API, that's the blue arrow, and provides an implementation of the service type, the purple arrow. Note that the logging implementation module does not export anything. Finally, the logging API module with the service type acts as its own consumer. It says that it uses the logger service type, and then at runtime it asks service loader for an instance of logger. This instance would then be returned up to the HTTP client module, which has no idea of the relationship between logging API and logging implementation. It occurs to me I should have deleted the big blue arrow from logging impl up to HTTP client. It should be gone. Pretend it's not there. I know you're all pretending it's not there right now. The HTTP client is forced to code strictly to the logger interface with no access to the underlying implementation class because it wasn't exported from logging impl. The great trick, basically, is that service loader acts on behalf of logging API to look down into logging impl. Without logging API requiring logging impl, and without logging impl exporting anything to logging API. In other words, there is very loose coupling between the API and the implementation. So it's easy to switch out logging impl for a different implementation at runtime. And again, the HTTP client module would be unaware of this happening. I need to speed up. If you get the feeling you've seen this before, it's because you have. 10 minutes ago, I said the way you get optional dependencies is by inverting them. Rather than the high-level scripting module requiring low-level implementation modules, everyone looks up by requiring the module with the service type. Services play the same trick to break a cyclic dependency. Rather than the high-level API module requiring the low-level implementation modules, the implementation modules look up by requiring the API module. Developing services takes work, but the payoff is that services bring out the structure of the whole program more clearly than anything we've ever introduced into the Java language. And since our number one belief for Java code is that reading is more important than writing, we think that services pull their weight and deserve to be widely adopted. So, cycles hurt program understanding and maintenance. Service relationships are a natural way to break cycles. And really, in just a few uses and provides and service loader calls, you can express an awful lot of application architecture. So services are first class. They literally give you looser coupling, but logically better separation of concerns. And it's all about the architecture rather than the code. JDK 9 is here. Please download it if you haven't. If you want to know more about the module system, there's a number of JDK enhancement proposals, JEPs, especially JEP 261. Basically every question that you're going to ask is answered in JEP 261. And with that, thank you very much.